Every year, the United States builds about 1.5 million new homes, and nearly all of them use drywall to finish their walls and ceilings. But have you ever wondered how such fragile-looking panels can become part of solid homes that stand for decades? Behind that durability is a demanding production line, where millions of tons of gypsum rock are mined, crushed by massive machines, heated in high-temperature kilns, then dried and cut on production lines stretching hundreds of feet before becoming finished panels. Right now, join Factron Process as we follow that remarkable journey, from raw gypsum to the walls that shape modern buildings. Each year, the world consumes nearly 18 billion square feet of gypsum board, making it one of the most widely used building materials on the planet. In the United States alone, more than 34 billion square feet of drywall are produced annually, and the material is found in over 90% of homes nationwide. The scale of this industry is so vast that the global gypsum board market is now valued at more than 55 billion USD and is expected to continue growing strongly in the years ahead. Its worldwide popularity, combined with the ability to meet strict technical standards, has made gypsum board a leading choice for complex interior structures. Today, this material forms the foundation of interior spaces in many of the world's most iconic mega projects, including the Empire State Building and One World Trade Center in New York, the Burj Khalifa in Dubai, Singapore Changi Airport, as well as countless large-scale hotels, hospitals, and shopping centers. To supply raw material for America's drywall industry, massive gypsum mines in Iowa, Oklahoma, and Texas move tens of thousands of tons of material every day. These gypsum deposits often occur as nearly continuous layers stretching for miles beneath the ground. Before each mining campaign begins, engineers use geological data and 3D modeling to pinpoint the exact location of high-purity gypsum seams. The goal is not simply to extract as much rock as possible, but to maintain a consistent chemical composition for drywall manufacturing plants. Once the mining area has been confirmed, large drilling rigs create a network of blast holes ranging from 20 to 50 feet deep. Electronic delay blasting systems then trigger each row of explosives, with delays measured in thousandths of a second. The most commonly used explosive is ANFO, a mixture of ammonium nitrate and diesel fuel that is both highly effective and well-suited for large-scale mining operations. Rather than creating a chaotic explosion, the entire rock mass is carefully directed to move along a predetermined path, significantly reducing oversized boulders and saving enormous amounts of crushing energy downstream at the processing plant. Within seconds, tens of thousands of tons of gypsum are released, exposing bright white quarry faces that resemble massive man-made cliffs. Immediately afterward, large tracked excavators equipped with buckets capable of holding dozens of tons of material begin loading the gypsum onto fleets of mining haul trucks, maintaining a continuous flow of raw material toward the primary crushing facility. Not far from the mining site, a massive primary crushing line is stationed outdoors, ready to handle the raw gypsum. The freshly extracted gypsum blocks are extremely heavy, making it impossible for them to move directly into the processing stages inside the plant. One by one, mining haul trucks dump the material into a feed hopper, where vibrating feeders regulate the flow of rock before sending it into a large jaw crusher. A fixed jaw plate and a moving jaw plate repeatedly press against each other, generating a crushing force that can exceed the equivalent of 600 tons. Each motion cycle breaks the large rock blocks into smaller fragments. Pieces that meet the required size fall through the bottom, while oversized pieces remain inside the crushing chamber and continue to be crushed through additional cycles. Gypsum rock can be reduced from blocks several feet across to fragments only about 4 to 8 inches in size. After primary crushing, the gypsum is transferred onto high-capacity conveyor belts. At the head of the conveyor, the material drops through transfer chutes and is collected into a central conveying system, maintaining a continuous flow of raw material toward the screening area or an intermediate storage stockpile. Before calcination, the gypsum is sent to the raw material homogenization area. Even though it comes from the same quarry, each deposit layer can have a different level of purity and mineral composition. Here, a stacker spreads the material into multiple overlapping layers, while a reclaimer removes it from the opposite direction to blend gypsum from different mining zones. As a result, the material fed into the plant has a more stable composition, allowing the later stages to run consistently and helping produce drywall panels with uniform quality. Entering the calcination area, the crushed gypsum begins the most important transformation in the entire production line. The material is fed into massive rotary kilns, dozens of feet long, where the kiln body slowly rotates to keep the gypsum moving and evenly mixed during heating. Here, the temperature is maintained at around 300 to 350 degrees Fahrenheit, hot enough to break the water bonds inside the crystal structure, but not hot enough to completely alter the mineral. Over several minutes, about 75% of the crystallized water is removed from the natural gypsum. As a result, calcium sulfate dihydrate gradually turns into calcium sulfate hemihydrate, commonly known as stucco. This is the moment when gypsum's real value is created. Before this stage, it is simply a white mineral rock. After leaving the kiln, it becomes a material capable of hardening again when mixed with water. Nearly every modern drywall panel begins with this chemical reaction inside these enormous rotating kilns. After leaving the calcination kiln, the stucco is sent to a fine grinding system to produce a powder with a more uniform particle size, typically around 50 microns. The finished material is then transported pneumatically to large storage silos, capable of holding hundreds to thousands of tons of product. Inside these silos, the stucco is kept in a dry, controlled environment to prevent moisture in the air from triggering premature setting reactions. When an order is received, the material is discharged from the silos and fed into high-speed automatic bagging machines capable of filling hundreds of bags per hour. Electronic weighing systems precisely measure the required amount of powder before it is loaded into multi-layer paper bags, most commonly in 40 or 50-pound sizes. Once filled, the bags are sealed, checked by a final weighing station, and transferred to the palletizing system. Each pallet typically carries 60 bags, equivalent to about 1 ton of product, before being wrapped for protection and shipped to drywall manufacturing plants across North America. After being transported to the drywall plant, stucco powder is fed into the central mixing system, along with water and specialized additives. In a standard formula, stucco typically makes up about 80% of the mixture, water about 18%, and all additives only about 2%. Although that 2% is very small, it determines many of the product's key properties. Starch helps the gypsum core bond firmly to the paper. Foaming agents create millions of tiny air pockets to reduce weight, while other additives control setting time, fire resistance, and moisture resistance. By simply adjusting the amount of air bubbles, drywall can become significantly lighter, while still maintaining the necessary strength and performance. Afterward, the mixture is continuously pumped through a network of pipes and deposited onto a layer of face paper that has already been unrolled along a production line that can extend up to 500 feet, preparing it for the drywall forming process. Before entering the board forming line, 2 industrial paper rolls weighing 3 to 5 tons and extending more than 20,000 feet are loaded into the automatic feeding system. Sensors continuously monitor paper tension to ensure the material does not wrinkle, shift, or tear while moving at high speed. At the same time, scoring wheels preform fold lines along both edges of the paper, preparing it to wrap around the gypsum core later. Only when the paper's tension, position, and shape all meet the required specifications, is the line ready for continuous board forming. At first glance, this paper may seem like nothing more than a simple outer covering. In reality, however, it is an essential part of the drywall structure. Made primarily from recycled paper fibers, it must be strong enough to support thousands of pounds of gypsum slurry being poured onto it every hour without tearing or deforming. More importantly, the thin paper layers on the front and back surfaces provide much of the board's resistance to bending during transportation and installation. In other words, the gypsum core supplies the mass and fire resistance, while the paper delivers much of the mechanical strength that allows the entire panel to function as a single, unified material. When the gypsum slurry reaches the required viscosity, it is continuously pumped through a network of pipes to the forming head of the production line. There, the mixture is spread evenly onto the moving face paper through a dispensing unit that spans nearly the full width of the drywall panel. The thick white slurry forms a layer about 1/2 inch, or nearly 13 millimeters, thick on the paper surface. The system must continuously control the flow of more than 600 pounds of gypsum slurry per minute. Even a small, uneven distribution in one area can immediately affect the weight and thickness of the entire drywall panel. As the paper continues moving at high speed, the gypsum core begins to take shape, preparing to be fully enclosed between the two paper layers of the drywall board. The entire process is controlled by the chemical reaction taking place inside the gypsum core, not by any press or heating system on the production line. At this point, the reaction between stucco and water is still occurring inside the material. New gypsum crystals gradually form and interlock with one another, causing the thick white slurry to begin turning into a solid mass. The drywall panel becomes firm enough to hold its shape and continue moving along the conveyor without deforming. This is the first moment when the product truly takes the form of a finished drywall panel, even though it still contains a large amount of water that must be removed in the next stage. Before being cut into finished panels, the continuous drywall strip passes through an edge forming system. Specialized roller assemblies fold the paper along both sides and create the characteristic recessed edges on the two long sides of the board. At the same time, the gypsum core continues setting as the material moves at speeds of up to 600 feet per minute. Length sensors continuously track the position of the product and send signals to the automatic cutting system. Once the required size is reached, the blade instantly travels across the full 4-foot width of the board and makes the cut in a fraction of a second. This process repeats continuously to produce panels 8, 10, 12, or 14 feet long before they move into the drying system. After leaving the dryer, the drywall moves into the finishing area. Mechanical handling systems rotate each panel into the correct orientation for processing, after which edge trimming machines remove excess material to ensure the board meets its exact dimensions. Industrial printers then apply information such as the brand name, thickness, length, product type, and identification codes onto the paper surface or board edge. At the final inspection station, industrial cameras and laser sensors measure thickness, flatness, edge quality, and surface condition. A high-speed production line can produce between 37 and 75 standard panels per minute. The panels that meet quality standards are transferred to an automatic stacking system. Here, the machines arrange them into bundles according to the correct thickness and size before identification labels are applied. Forklifts continuously move the drywall bundles from the end of the production line to the finished goods warehouse or loading area. A specialized truck can carry between 800 and 1,200 drywall panels in a single shipment. Large plants can ship more than 1 million square feet of drywall each year. From there, the product is distributed to building material suppliers, housing projects, hospitals, schools, offices, and airports across the region. After arriving at the construction site, the drywall panels are fastened to steel or wood framing using specialized screws. The panels are positioned tightly against one another to create a continuous surface before workers begin finishing the joints. paper tape or fiberglass tape is applied over the seams, followed by multiple coats of joint compound to fill the recessed edges and conceal the screw heads. Once the compound has completely dried, the surface is sanded smooth and prepared for painting. In a relatively short time, these simple flat panels begin to transform into walls, ceilings, and complete living spaces. This is also why drywall has largely replaced traditional plaster wall construction throughout the modern building industry. For many years, the drywall industry relied primarily on gypsum extracted from quarries. Today, however, a growing portion of the raw material comes from sources that few people would expect. At recycling facilities, old drywall panels are crushed to separate the paper from the gypsum core. The recovered gypsum can then be processed and reused as a raw material for new products. A single drywall panel may remain in service for 30 to 50 years before entering its next life cycle. Once cleaned, this recycled gypsum powder can be returned to the production of new drywall, used in cement manufacturing to control setting time, or applied in agriculture to supply calcium and sulfur to the soil. The challenge is that the material must be carefully sorted, since drywall from demolition projects may contain paint, screws, wood, adhesives, or other contaminants that are unsuitable for reuse. For this reason, gypsum recycling is far more than simply crushing an old building material. It is a way for the construction industry to recover a mineral that still holds significant value, reduce the amount of heavy waste sent to landfills, and lessen the need for additional mining.